Yes, my name is Jim Wetzel. I'm Director of Global Reliability at General Mills. I've been there 31 years, so very similar to Miguel's history. And in global reliability, what I'm responsible for, this is an engineering function, I'm responsible for improving, sustaining, and extending the capability of our assets across the globe. So making more with less, improving maintenance and reliability of the assets, optimizing our production processes through control, through information, through automation, through people, through continuous improvement. All of that space is what I do for a day job. In my spare time, I'm also the chairman of the Smart Manufacturing Leadership Coalition. So Miguel, I didn't know you were going to talk about smart manufacturing in the way you did, but you got it all spot on. So thank you for that. It was actually perfect. In the Smart Manufacturing Leadership Coalition, we have been blessed by getting an award from the Department of Energy, and they gifted us $70 million to actually create a Smart Manufacturing Innovation Institute to actually go do what a lot of things Miguel was talking about. I'll talk a little bit more about that. And we are going to be standing up that institute. Looks like probably January 1st. We're in the final paperwork of getting that documentation and whatnot signed with the Department of Energy. Looks like about the middle of next week that'll happen. And then January 1st will be open for business as a Smart Manufacturing Innovation Institute. What I'm going to tell you today is really, I'm going to do some storytelling about our journey to smart manufacturing, and I'm going to go through 3 different use cases where we've applied some of the principles that you've heard already this morning. So I'm going to talk a little bit about who we are, what our challenges are, what supply chain looks like. I'm going to talk a lot about this topic of connections. This Internet of Things, connecting of things, and so on, and really what insight we've had so far at General Mills as we've tried to do this, and what some of the challenges still are. I don't know if this is going to play. No, it's not going to play. General Mills is a 150-year-old company. So Bosch was 130, and Boeing, I think Boeing was celebrating 100. So we're 150. So obviously people ate food before they flew. So Richard, I'm trying to have you take back those words that you said. Those first 2 presentations would be the most exciting presentations. And then
so you really talk about airplanes?
I will weave airplanes into my speech. But our business is quite interesting. Obviously we make food. We are 150 years old, and our current volume is we're about an $18 billion company. In the food industry, Nestle, our friends at Nestle's would be number 1 in the world. General Mills is about number 5 in the world. And you take a look at our business, globally, we make products. It's packaged foods is what we make, cereal, snacks, yogurt, super premium ice cream. Oddly enough, we make ice cream for the rest of the world under our Haagen-Dazs brand, and our friends at Nestle's have the Haagen-Dazs brand for the United States. So you would think that would be kind of backwards, being Nestle's in Switzerland and General Mills is in Minneapolis, but that's just the way business is working, but we both make Haagen-Dazs. I'm going to tell you a little bit about the supply chain at General Mills. Just to ground us because people use the word supply chain and it doesn't necessarily mean the same thing everywhere you go. Our supply chain, as we think about end-to-end, includes our suppliers, raw materials, the plants and manufacturers, logistics, and our customers. Just like Nestle talked about, we have to do this very safely and environmental friendly and with social responsibilities and for sustainability. We have 45 plants that we own across the globe. We keep reducing them and making more mega plants. So we've gone from a lot of, probably, let's see now, 10 years ago we had north of 80 plants, and now we have almost half of that through consolidation and moving towards larger facilities. We have a 50-50 joint venture with Nestle to make cereal in the rest of the world outside of North America, outside the United States. And that joint venture has 17 plants in addition. And on the General Mills side, we provide the technology for all of that. And then we have a joint venture on Haagen-Dazs in Japan. In our supply chain, we have 23,000 employees. General Mills has about 40,000 employees as a company. 23,000 of them are in the supply chain. And about a quarter of our business, we actually use contract manufacturers for our food. So we have over 200 contract manufacturers. Of the contract manufacturers, roughly 150 to 170 of those are in the United States, and 25 to 50 of them are in the rest of the world. So when we think about trying to get to smart manufacturing, we think about our ecosystem. We have small, medium, and large enterprises, manufacturing plants that we have to do business with. We have small, medium, and large folks that are both in our own network as well as outside of our enterprise, so with our contract locations. So when you go to the grocery store and you buy our product, it says General Mills on it. It doesn't say contract manufacturer on it. It says General Mills. So we're responsible for the safety and quality of that product no matter where it's produced. So we leverage our partners that we work with in a big way. And you think about our company, our technical staffs are pretty darn lean in the food industry. In general, our margins are pretty lean compared to some of these other businesses like automobile and airlines. So we leverage our partners to really work with us closely on what are our ingredients, what are our materials, as well as the technology and services that we need to have. And then jointly around thought leadership around how to change the world and how to head towards smart, because at the end of the day, our job that nobody else does is we make food. And I'll tell you in a couple slides here, I'll talk about our journey. We've made a lot of software in my 31 years, but our company makes food, and that's our excellence. And as Miguel talked about operational excellence, it's around making the product. Unfortunately, because some of the product offerings in the marketplace haven't met our needs, we've actually had to provide software solutions as well. When we talk about these partners, we're really looking at them for innovation and reliability and scalability and connectedness and standardization. And probably the biggest thing, and this comes right back at us in this industrial internet, we have to leverage past investments. So in our business, we don't get do-overs. So a lot of our factories will be from 1 year old to 50 years old. And we have to, when we come into the factory and try to optimize it, we have to meet people where they're at. We don't say, okay, this Internet of Things that you heard about and you read about, first thing you need to do is start over. We got billions of dollars of assets, so starting over is not the right answer for us to move forward. We have to figure out, how do we meet people where they're at? How do we optimize production? How do we get after excellence? How do we understand how to connect our suppliers to our factories and our factories to our customers without the first answer being starting over? And I'll give you a couple examples on that. So I'm going to tell you some stories about connecting. And then I'm going to end with another. I'll tell you the punchline before I start, is that connecting is not where I'm going to end this story with. GMI's journey to connected. So if you think about what Miguel talked about around those 4 different enablers of smart manufacturing, I'll tell you the same story, but I'm going to do it in a timeline. Because our paths are similar, and quite honestly, the 3 speakers before me with automobile and the airlines and then with another food company, our stories are almost identical. And I know I didn't see anybody else's deck. I assume nobody else saw each other's decks, and it's amazingly how similar we are. So 1993, I was in the control and automation group, and my challenge was to figure out what is our strategy and architecture and roadmap to move forward. We didn't have a roadmap in 1993 to smart manufacturing. We didn't have a roadmap in 1993 to Internet of Things. None of these topics existed at the time. But we had this brilliance, and we said, you know what? Anything that we buy, we should connect. And then what are we going to do with it? We're going to put a data historian on it, and we're going to call it a data vacuum cleaner. And we're going to suck up all this data. And what are we going to do with it? The chevrons across the bottom of this slide talk about what we thought we were going to do with it. We're just going to trend stuff. Because as you get into problem solving, as you try to get into continuous improvement, if you don't just have the raw data to look at some information, your people can't go and do troubleshooting. And in 1993, we were just moving out of the era of strip chart recorders and pencil and paper, and computers were starting to show up on the factory floor. But most of them didn't work much of the time, because what operating system did the computer have that we didn't like? Microsoft. No controls engineer in their right mind would ever install a Microsoft operating system in a factory in 1993. Spin that clock back up here to 2016, and now that's the operating system of choice. So we said what we're going to do is we're going to hook up all these devices. Every single PLC. We will not buy another PLC in General Mills we can't put on Ethernet. 1993. Lots of data. Visualize. Trend it. So we had a historian. We helped create a lot of the historian technology that's out there today. We actually used the historian technology that Boeing and Weyerhaeuser created in Seattle. 1998, moved the next step. We said we need to go after quality and manufacturing analytics and reporting on our product. So just like Miguel said, in the food industry, we have to make sure that the product has high quality. Because why? It goes in you. If we make a mistake, people get sick. I guess you could say the same thing is true in automobiles and airplanes. If they screw up and the product goes in you, you'd have a trouble. If the airplane went in you, you'd have a problem. If the car went in you, you'd have a problem. But that's not normal. In food, the normal behavior is eat it and you're fine, and it's providing you all the nutrition and so on. So quality is really important. Manufacturing excellence is really important. So actually, I went live in 1994 and built our first MES system. By 1998, we had that deployed across all of our factories in the world. Homegrown application. Why? Because it didn't exist in 1993. People were just starting to create and come up with these MES kinds of ideas. That there was a handful of products that were coming into market, but it wasn't predominant. So just like I said, we make food, we built software. That software still exists today. It is 22 years in running. We have updated the technology 5 different times, from Unix to Java to .NET. Our database structure is all changed so we can keep up with the Joneses and be modern. But 1998, why are we going to do this? We have to drive quality in manufacturing. 1999, IT-OT conversions. So you think about the 2016, 2014, control, all these folks talking about it. In 1999, we converged IT and OT. We converted the IS organization, the engineering organization, to support manufacturing under me. So I was the one running it and created one team. 2004, we went after enterprise analytics. And we said we need to get after this space called manufacturing intelligence. We need to do dashboard and centralized data, enterprise, and the concept of one global plant. In 2004, imagine the disturbance that you would have for a sales guy of software when the first thing they ask a major multinational company is how many plants you have when they're trying to figure out the licensing strategy of their software. And the answer by me is 1. And they go, how can you have 1 plant? I read in your corporate report that at the time you have 80 plants. And I go, well, the equipment doesn't know it's in a plant. We're trying to get after one enterprise. So as far as I'm concerned, we have one factory. It's connected. It's got a lot of devices on it. Well, but our pricing model is we're priced per plant. And I go, well, I guess we get a good deal. We have 1. What's the price of 1? And maybe we do the first one as a pilot. So that was real disturbing and kind of disruptive for a lot of the software business models, is when you think about having your systems in a connected state And literally, they do not know where they're at. It's just about electrons moving around and giving information. All of a sudden, now it's disruptive to old-fashioned licensing models, and that's where this whole internet thinking needs to really drive this. 2007, we said, you know, this MES stuff that we did back in 1998 that was all about quality and manufacturing really needed to start integrating and do demand-driven supply chain. These transactions, Miguel talked about a couple of them, but these transactions about process of production orders and making sure you're making the right quantity, not too much, not too little, just right, kind of like the three bears. Integrating SAP, doing inbound management, direct consumption on the factory floor, production orders, and actually the biggest thing that we did that you don't hear a whole lot about today is managing work. So we still have people in our plants. And as you think about the Internet of Things, we talk a lot about making devices to devices smart and stuff. And we're not hearing a whole lot about, so how do people engage in this? And so for us, it's a combination, we call it the 4 M's, around man, material, machines, and methods. And all 4 of those have to play together for us to be successful. And if you over-index on one and under-index on another, your house is going to fall down as well. So don't forget about the people in this equation. And so one of the things we did was we said, what technology and what approaches can we use to go after and managing the work that people do? And when there's an exception, what's the process of an exception? And how can technology enable that? How can you do that more efficiently and more accurately? And so this concept of managing how people work, we put into our smart manufacturing journey. And today, we're looking at, we have historians in the cloud. I'll talk a little bit about this traceability application, supplier managed inventory, so vendors can actually help us, and we work out contractual agreements with vendors to say, make sure we never run out of sugar, make sure we never run out of flour. It's not our job to manage it and constantly order stuff, but really giving full visibility of what's going on in our manufacturing space to all of our suppliers so they can help us. This concept of transparency and visualization is being quite refreshing in our supply chain business, and I'll have a use case about that. So, like all companies, you know, we're in an economy that's forcing all of us to do more with less. And for us, it's about increasing our asset intensity, basically using what you have. It's about connecting across boundaries between different divisions. As you think about our supply chain, is very robust. And then the last thing, which we tend to do a terrible job on, is having systems that are agile. So as a big food company, we like to also make big food. We like long runs. So you think about this and you go, well, what if the customer doesn't want Cheerios in a particular box size? They want Cheerios in a small box, a large box, a certain commercial or advertisement on that. But the base product's the same, but how it's packaged is all unique. And how do we make these short, quick, nimble runs and get in, get out? When in fact, everyone that's in the manufacturing space, what does everyone yearn for in manufacturing? Making one product and staying on it for long runs so you can really drive efficiency. What if everything has to be unique? So what's different and the same, if you think about the automobile industry, they've got a lot of customization, right? You can buy one car at a time. Each car can be uniquely made. But that's a discrete process. In making food, by and large, it's a continuous process. So how do you make every pallet, every package, every product unique? We struggle with that. So we have this tweener category where we desire to be agile because it's what the business really needs. We don't know quite how to do it. This idea of transparency has really started to open our eyes, and kind of the theme, that the words you'll see us talk at General Mills is about, what if we created windows where there currently are walls? As you think about the walls that we have up of suppliers and manufacturers and warehousing and transportation and customers and consumers, and then you think about the functions in an organization that support those areas. Do you think the supplier, as an example, the simple one that I just gave, do you think that the people that are the suppliers to General Mills know the quantity of products that they need to, that they need to provide us in real time. They get an order from us. Please ship us 1 million pounds of flour tomorrow. Really? Well, how many did you need? Did you need 1 million or did you need 500,000? What's the level of your silo? Well, the sourcing organization is still in this purchasing kind of mentality, and we don't have this real-time view. As we took a brief look at this, for us, there's over $100 million of value in creating windows where there's walls and adding transparency to the different functions about what's going on in this ecosystem called the supply chain for General Mills. And this concept of unlocking the productivity and accelerating growth, at the same time strengthening the trust of our consumers because we're more visible to what's going on in this network, is a very powerful concept. Because at the end of the day, you know, when you go to the store and you buy our product, you're buying it because you trust us. That when you buy that product, you can trust that it's good quality, it's safe for you, it's a good product, it's a good value, all that kind of stuff. And so at the end of the day, we say, yes, we talk a lot about the brands and the products that we sell, but for you to put your money down at the moment of truth where you're actually buying something in the grocery store, we really believe that it's an equation of trust. And we cannot violate that trust. So here's the scenarios that go, the use cases where we've taken these concepts, where we've laid down this PLC and data information and actually gone after, and I'm going to quickly go through 3 use cases. A little over a year ago, I was here in California. It was one of our lines in our Los Angeles plant, we make Yoplait, was running at about 30% efficiency. And we needed to double that. We needed to double that capacity of that line. It's a high-speed packaging line. You can see the yogurt coming out in 6-packs and 8-packs. So how do you eliminate losses, drive system efficiency, make sure you have first-pass quality, have zero unplanned failure, and free up capacity? And do that starting tomorrow when your plane lands. That was my challenge. And we 2.5 times the system efficiency and capacity in 10 days. And the way we were able to do that was to be able to actually leverage I like that word of, what was it called, data exhaust. We took a look at that. No one was looking at all the millions of data points a day that was generated from the system. So at General Mills, across the network, we have 700 billion data points a day that the system collects. No one in the factory was looking at it. By analyzing that data, by understanding that system, by understanding in milliseconds the responses of servos and motors and stuff like that, we were able to troubleshoot it from an engineering perspective and get this line up and running. Second use case, connecting across boundaries, field to fork. General Mills last June introduced a product launch of Cheerios that's now gluten-free. Well, here's the thing interesting about Cheerios. Oat flour, which is 90% of the product in Cheerios, has always been gluten-free. There's no gluten in oats. But here's the trick, guys. There's gluten everywhere else. There's gluten in the farm fields because the purity of a farm field, when birds can take seeds and drop seeds in neighboring crops, the truck that comes by that just filled up the farmer's wheat crop and now is running down the road and is going to connect the oat crop, it gets contaminated. And so the challenge we have is how to find this 1 in a million defect. And so literally it kind of goes like this flow of oats story is we come from the field, we go into contaminated silo bins. In the middle you can see the grain of oats, and literally we have to find 1 in a million that's not oats to be able to be gluten-free. And then we transmit this by train, then we go into a processing mill and a plant, we convert that stuff into whole ground oat flour, and we run it down to our factories. This is a huge genealogy question. Very complicated scenario, very complicated manufacturing. And the thing that's unique about this, we don't own the whole thing. So about half of this equation is outside the walls of General Mills. So you think about the Internet of Things, industrial Internet of Things, the problem we have to solve is connecting with others. not just connecting with ourselves. And I'll talk more real briefly about that. The last example is creating agility with information. This is a factory in Joplin, Missouri. We have 1.5 million pounds of wheat flour coming to that plant today. It has 24 silos in it. It actually makes Pizza Hut pizza dough. It makes Red Lobster biscuits that everyone loves, that you can't eat just one. Kentucky Fried Chicken biscuits as well. 10,000 finished pallets per day, 500,000 finished cases, and challenge. We have $5 million worth of raw material inventory. Through connecting all of this information together, we're able to manage this plant on a shoestring. We're able to have our raw material inventory accurate to $500 per day, and I'll show a slide in that. We produce just in time, and quite honestly, here's a fun fact. We got called by Pizza Hut. This is about 2 years ago. Pizza Hut called us up and said, we're running a special at Super Bowl. We're going to offer $10 pizzas at Pizza Hut. Guess what happened to Pizza Hut's business? $10, any size. Went way up. What if you were the local franchise of Pizza Hut and you had no dough? It's like McDonald's with no fries, it's Arby's with no roast beef, it's Pizza Hut with no pizza dough. And they can say, well, we can give you gluten-free pizza, it's just the toppings. But no, they wanted and you can eat the box probably. So they called us up. They called us up in a panic, and they called up this plant directly and said, "Can you make more?" And because we'd integrated every single one of the systems, we had our suppliers, the plant, the warehouse, the transportation, the storage, and the consumers in this particular case connected in real time, and the flow synchronized. We created a transparent supply chain for this business. It allowed us to reduce our raw material time and in transit time. It gave us a better flashlight to take a look at where savings and opportunities were, and drove agility to get extra business away from our competitors, because we could respond in time and speed that nobody else could. And that's what SMART did for us. So we had value creation in these three examples that were all about improving safety, increasing our sales, reducing our costs in manufacturing, improving our customer service. This left-hand slide is really to talk about as we're doing this and trying to go down this journey of SMART, what did it do to our safety culture? At the same time, what did it do to our productivity? So the yellow line is the number of incidences in TIR, and you can see it dramatically decreasing over this same time period. And the blue bars is our productivity per unit input. And again, that was really increasing. The new challenge that we're on, and Miguel talked about this visibility and visualization and analytics side, is we're really going after insights into our opportunities. This concept that consumers want to know about what's in their products. They want to know that it's real food. The concept is, you'd be able to scan your box of Cheerios, you'd be able to meet the farmers that made it, understand the cows that made the milk in Yoplait or ice cream. We have that technology to be able to do that. Our story that I told you that started in 1993 kind of simply can be looked at this way from a connecting to creating value standpoint. Is we started at the equipment. So very much like Miguel said, where do you start? You start with collecting data. But here's where we started to differ from others. Is yes, we did equipment. Yep. Once you got equipment, you worry about systems. When you got systems kind of nailed, you worry about a plant. When you have a plant nailed, then you worry about the enterprise. But what we're worrying about is the ecosystem. Because at an enterprise level, we can't solve our problems because we have to work with others. We have to work with our partners, we have to work with our customers, we have to work with our suppliers. So if smart manufacturing stops inside the walls, there's a lot of money to be left on the table. And it's a much more complex problem of trying to figure out how to integrate people's data, people's information. How do you connect with different business systems? Because we're not wired that way. We have a hard enough time doing it in our own company, let alone doing it with others. And so I started this story talking about connecting, but quite honestly, the biggest challenge I had was around contextualization. And then trying to figure out the value is coming from the contextualization. So I applaud everyone, I applaud the industry for working on connections. Absolutely, that's the right thing to do. It's not sufficient to solve our problems. Having data having information that all it knows is date, time, and value. It doesn't know everything that went around. It doesn't know the quality of a product. It doesn't know what people are doing. The human being does a very good job of contextualization. Systems don't have all that extra knowledge. So the challenge that we have, and we're doing this in our oat flour example, is we've layered in data modeling and contextualization engine into the cloud to take these different sources and contextualize it so we can actually connect up the story from field to fork. And we truly believe that's where the value is actually going to be created. So with that, I end and let you know we do make food. That's our job.